when I think about the big questions, I tend to organize them into origin of the universe, origin of life, and origin of mind. And I'm actually teaching a course with that theme at Columbia, and we read The Selfish Gene this term as part of that. I hadn't read it since I was in college, so it was spectacular to re-engage with the wonderful book that you gave the world. A question came up in the class.
All right.
And I would like to check with you to see if the answer I gave makes sense and aligns with your thinking. So the question a couple of kids asked was, look, we read this book and we get a very clear sense of evolution, the gene as the basic unit of heredity, but we're still left with the question, what is life and how did life get started? So my response to that, which some of them found quite unsatisfying, is that that's not as precise a question as you think, right? I mean, in some sense, trying to draw the line between animate and inanimate and trying to have a very precise definition ultimately amounts to words, right? It's a continuum from inanimate to animate, and once we have the molecular Darwinism in place rolling forward, life just emerges in that continuum. So my question to you is that a reasonable way of describing it?
I think it is. I think that there's a too great a tendency in the human mind to try to draw lines and to try to, where there is a spectrum. I mean, sometimes there really is a line, but in other cases there isn't, and we should not insist that there has to be a line. Well, in the case of life, I suppose you could sort of see a kind of line when the first self-replicating entity came into existence, because that was the moment when natural selection, and hence Darwinian evolution, could start. You can't get natural selection unless you've got something equivalent to a gene. So the first gene, which would not have been DNA, by the way, but the first gene would be a kind of watershed event, I suppose. But I agree with you, we don't want to get too hung up on the questions of definition, like definition of life, as opposed to non-life,
right,
which demand a particular moment at which life came into existence.
And when you say first gene, in that context, can I think of it as the first molecule that discovers this capacity for making copies of itself, period?
Yes, making copies of itself, and that would include making copies of errors in itself.
Right.
So that there has to be variety in the population of these replicating entities. The reason I say it wouldn't have been DNA is that DNA has been described as a high-tech replicator that requires a rather complicated infrastructure of biochemistry in order to do its replication. So people in the field agree that the first replicator would not have been DNA. It would have been something else that had the property of self-replication, probably much less efficient at it than DNA. And DNA would have been a late usurper of that role. It could have been RNA.
And do you think it was RNA?
I don't know. I mean, that's a current fashionable idea. And the reason it's fashionable is that, as you know, there's a kind of divide in biochemistry between the protein, which acts as enzyme, and the variety of enzymes, which is the key to everything that goes on in life. The fact that the three-dimensional form of a protein molecule, when it coils up into a sort of knot, which gives it its enzymatic properties, and that is determined by the one-dimensional sequence of amino acids, which in turn is determined by the one-dimensional sequence of DNA. So there's this double act between DNA and protein. DNA is not an enzyme, it's an excellent replicator. Protein is an excellent enzyme, but cannot replicate. RNA is kind of moderate at both. So if it started off with RNA, that could have done both the enzyme role, because RNA is a kind of rather bad enzyme,
right,
and a kind of rather bad replicator, but it can do both roles. And so the idea is then that DNA would have come in and usurped the replication role, and protein then came in and usurped the enzyme role.
So how big a molecule do you imagine this first replicator would be?
I suppose it would be quite small, the first one.
Right. I mean,
But I don't know. I mean, this is an active field of, well, I suppose research, but very speculative research.
right. Because, you'll see people making the argument that whatever molecule you put forward as the first one, if it has some degree of complexity associated with it, you can then ask yourself, what are the odds that that molecule will form? And when that number is necessarily quite small, some people see a tension with the naturalness of the process and the unlikelihood that it would happen. So how do you answer that?
Well, it is a field where there is no answer yet, and people are not confident of it. There are various problems with the so-called catch-22, that you can't get DNA without protein, and vice versa.
Right.
There are other problems with it. Some people have favoured what they call a hypercycle, where there are various stages in a chain, and each stage gives rise to the next. So there's no one molecule is the key replicator. The entire hypercycle is the replicator. But it's not a field which has been solved. It's not a question which has been answered. It is still conceivable that the origin of life, the origin of self-replication, the origin of natural selection, was a stupendously improbable event.
Right.
And the corollary of that would be that there's no other life in the universe. I mean, or put it the other way, if you want to believe that there is only one life form in the universe, which you're entitled to do, then a corollary of that is that the origin of life on this planet must have been a fantastically improbable event, so much so that any theory we come up with has got to be a very implausible theory.
Right.
Because if it were plausible, there would be life all over the universe,
Yes.
which I suspect there probably is. I'm just saying that if you want to believe that life only arose once, then what you're looking for in a theory of the origin of life is not a plausible theory such as you could replicate in a chemistry lab.